Every anti-detect browser profile screen has a field for CPU cores, and on the older builds, one for battery status sitting right next to it. Most people click through both without ever asking what that number actually does once it leaves the settings panel and lands inside a browser tab that a website can read the instant the page loads. I run real proxy and cloud phone farms, and I test these browsers against the same detection scripts that ad networks, banks, and social platforms actually run in production, not against some toy demo page. So I want to walk through what these two signals measure, why they got built into fingerprinting scripts in the first place, and where spoofing them genuinely helps versus where it just quietly falls apart. That is a JavaScript property that returns how many logical processes your browser thinks it has access to, which usually means physical cores multiplied by however many threads each core can run. It is not a hash and it is not a guess, it is a direct read of your machine's reported thread count, 4, 8, 12, 16, 24, whatever your CPU actually exposes to the operating system. Any page on the internet can read that value with a single line of code. No permission prompt, no click, no user gesture required from you at all. On its own, that number carries very little weight because millions of laptops out there report 8 cores, but it never shows up alone in a real fingerprinting script. It gets stacked together with device memory, which is a rounded, deliberately vague RAM figure that Chromium caps at 8 GB even on machines with far more installed, plus screen resolution, the GPU renderer string pulled out through WebGL, your time zone offset, and a handful of font and canvas measurements that ride along quietly in the background. Once you stack 5 or 6 of these individually coarse signals on top of each other, the pool of plausible matching devices narrows down fast. A script does not need your core count to identify you all by itself, it just needs that one number to help rule out every machine you clearly are not, until what remains is a small specific handful of real devices that could plausibly be sitting behind that session. That is also why this particular value matters more for consistency checks than for pure uniqueness. A detection system is not really sitting there asking whether 8 cores is rare because it knows it is not. It is asking whether 8 cores make sense given everything else that same session is telling it about the device in front of it. That pattern, one core's hardware value combined with several others to shrink a pool of candidates, is basically how every browser fingerprint works underneath the marketing language. Cores and memory are the hardware half. Canvas rendering, audio context output, and installed fonts are the software half. The battery status field sits right at the boundary between the two because it looks like a hardware reading, but it behaves statistically like a session identifier. The battery AP, exposed through a call named getBattery, is older than most of the other fields on a typical profile screen, and its history tells you a lot about how fingerprinting defenses actually evolve over time. When it first shipped in browsers, it exposed charging state, current charge level as a percentage, and an estimated time remaining until full or empty, all reported with far more decimal precision than any real user interface would ever need to show a person glancing at a battery icon. Researchers demonstrated back in 2015 that the combination of charge level and discharge time estimates changed often enough and was reported precisely enough to re-identify the exact same laptop across separate browsing sessions, even after someone cleared their cookies, switched to a different browser on the same machine, or opened a private window specifically to avoid being tracked. The battery reading was quietly functioning as a tracking cookie that lived inside hardware state instead of inside storage, which meant none of the normal privacy tools people reach for actually touched it. That research is exactly why browser vendors backed away from the API once they understood what it was doing. On desktop, Firefox pulled default support for it entirely, and Safari never shipped it for the web platform in the first place. The one holdout is Chromium, which kept getBattery available for compatibility. But even there, the precision and the availability of the values it returns have both been tightened considerably compared to the original specification from a decade ago. The practical result today is that a real current Firefox or Safari session simply will not answer a battery query the way browsers once did across the board, and a real current Chromium browser answers with a lot less decimal precision than fingerprinting scripts got used to reading years earlier when the APE was still wide open. That history matters enormously for anti-detect testing because it flips the battery field from being something you carefully spoof to look convincing into something whose mere presence or format can be the tell-all by itself. If a profile is pretending to be Firefox on desktop but still answers a battery query with an old-style precise discharge estimate, there is not a strong, hard-to-crack fingerprint. It is a bug that no real current Firefox installation would ever produce, and a script built to notice exactly this kind of mismatch does not need anything else from the session to flag it. The core mistake I keep seeing people make with anti-detect profiles is treating each hardware field like an independent knob you can set on its own. Cores to 8, memory to 16 gigs, done, move on to the next tab. But a real detection script does not read these fields one at a time in isolation. It cross-references every value against every other value on the same session and looks for a story that does not add up. If a profile claims 16 logical cores and 16 gigabytes of memory, but the WebGL renderer string resolves to a low-end integrated GPU that has never once shipped inside a machine with that kind of CPU and memory spec, that is an internal contradiction a script can flag without needing any browsing history on that visitor at all. It does not need to have seen the device before. The contradiction is sitting right there in a single page load. The same problem shows up with a phone-shaped user agent claiming 12 hardware threads, when the overwhelming majority of real mobile chipsets out in the field, across Android and iOS both, report 4, 6, or 8 logical processors and a number outside that narrow, well-known range on a device pretending to be a phone is exactly the kind of detail that stands out precisely because it is too high, not too low. The other failure mode, and honestly the more damaging one, is uniformity across a whole batch of profiles rather than any single number being wrong. If a farm spins up 50 profiles and 48 of them report the exact same core count, the exact same memory figure, the exact same GPU string, and the exact same screen size because they all came from one saved template with only the user agent swapped between them, that combination becomes a fingerprint of the tooling itself rather than a fingerprint of any real device. Real device populations out in the wild have a messy, uneven spread of these values because real people buy whatever laptop or phone was on sale that year. A stack of identical different looking visitors is its own signal, and it is honestly one of the easier patterns for a platform to catch because catching it does not require tracking any single visitor over time or building a profile on them individually. It just requires comparing sessions against each other and noticing that dozens of supposedly unrelated people are all running suspiciously identical hardware. I am not going to hand you a benchmark number here, and I am not going to invent a pass or fail rate for any specific product just to make this sound more authoritative than it actually is. What I can tell you from hands-on testing across tools like multilogin, GoLogin, Camilio, AdsPower, and Dolphin Anti is that every one of them exposes core count and, where relevant, battery fields as configurable settings sitting right there on the profile screen. The meaningful difference between these products is almost never whether that field exists, it is whether the rest of the fingerprint around it, GPU string, fonts, audio context, timing behavior stays internally consistent with whatever operating system and browser version the profile is claiming to be. If you are evaluating any anti-detect browser on this specific axis, rather than taking a sales page at its word, here is what is actually worth checking with your own eyes. Does the spoof core count fall inside the real-world range for the device class and operating system the profile claims to be running? Does the memory value scale sensibly against that core count? Since real hardware tiers almost always pair the two together in predictable bands rather than mixing a high-end chip with entry-level RAM. Does the GPU renderer string match a machine that would plausibly ship with that exact CPU and memory combination in the first place? Or does it look like someone picked 3 unrelated components off 3 different shelves? And separately, if the profile claims to be a browser that removed or restricted the battery APE, does it actually behave that way under a direct test, or does it still quietly answer old-style, overly precise battery queries underneath the surface? One more thing worth checking across a whole batch of profiles, rather than just one, is whether there is real variance in these values from profile to profile. The kind of natural spread you would expect from 50 different real owners buying 50 different machines, or whether everything looks copy-pasted from a single saved template with only the visible label changed. None of this makes any profile undetectable, and no anti-detect vendor can honestly promise you that a coherent, internally consistent fingerprint alone means an account will survive a platform's other detection layers. Behavior analysis, IP reputation, login timing, and account history all sit on top of the fingerprint layer, and any one of them can flag a session that sailed straight through every hardware check without a single contradiction. Fingerprinting is one detection layer among several, and hardware fields like cores and battery are one small part of that one layer alone. Battery and CPU fingerprinting exist in the first place because browsers expose more machine detail than most people ever stop to realize, and because that detail turned out to be stable and specific enough to help re-identify a device across sessions long before anyone called it a fingerprint. Antidetect browsers give you the controls to change what these fields report back to a website, but the actual value of that control depends entirely on whether the rest of the profile agrees with the story those two numbers are telling on their own. A spoofed core count that contradicts your GPU string, your memory value, or your claimed operating system is worse than never touching the field at all, because now you have handed the detection script a clean, obvious contradiction to work with instead of just an ordinary, forgettable device that blends into the crowd of everyone else browsing that day. I test these browsers on real multi-account setups, so the written reviews and the picks I actually trust are all at antidetectreview.org. Full written reviews and tested picks at antidetectreview.org. And if this kind of breakdown was useful to you, go ahead and subscribe for more.